Hello everyone, thank you for joining me for one more transformation. We're going to transform the absolute value graph. I know that because I see the absolute value bars in that transformed function right there. Now normally we love transforming the absolute value function because it's nice and straight. We don't have to worry about drawing any curves. So I took the liberty of making this one a little bit more difficult by dropping that nasty looking fraction of -1/3 in front. Now let's do a little planning ahead. Because there's a -1/3 in front, at some point we're going to have to multiply all of our y values by -1/3, which basically means dividing by -3. So what would be awesome is if all of our y values were divisible by 3. So for this particular problem, we don't often have to do this. I'm going to use a special set of ordered pairs that still represent the graph of absolute value of x, but are going to make it easier with that -1/3 there. Check it out. -6, 6, -3, 3, 0, 0, 3, 3, 6, 6. Still all ordered pairs in the absolute value function, but both 3 and 6 are easy to divide by 3. So this will actually make our job a little bit easier. Let's see what else we got going on here. We got the +2, the -4, and of course the aforementioned -1/3. The +2 is going to shift our whole graph up 2 units. We accomplish that by adding 2 to y. The -4 on the inside is going to shift our whole graph to the right 4 units. So we're going to add 4 to x. That's the backwards one. And then the -1/3 in front actually does 2 things. It does a reflection over the x-axis, and it also shrinks our graph by a factor of 1/3. So we can accomplish both of those things at the same time just by multiplying all of our y values by -1/3. So multiply y by -1/3. By the way, that's the same as divide by -3, which might make it a little easier if you think about it that way instead. We only have to do 3 things. 1, 2, 3. Does order make a difference? It can. So we're going to make sure we follow the correct order. Horizontal shift first, vertical shift last, and we'll do this doozy of a step right in the middle. Okay, first step, not so bad. We're just going to go across and add 4 to all the x's and leave the y values alone. So -2, 6, 1, 3, 4, 0, 7, 3, 10, 6. Yep, just added 4 to all the x's, but I left the y's alone. All right, now is the big step where I'm going to multiply the y's by -1/3 or divide them by -3, however you want to think about it. But it's not so bad. You see, first of all, let's make sure we leave the x's alone. Let's make sure we leave the x's alone. Don't want to accidentally fiddle with those. Now I'm going to go through and divide each one of these y values by -3. Watch this. That'll be -2, -1, 0, -1, -2. Just like that, because I picked some smart ordered pairs to start with. And there's not a lot of examples we have to do that, but it made this problem easier. All right, finally, we're going to add 2 to all the y values. All right, let's see what we got here. -2, 0, 1, 1, 4, 2, 7, 1, 10, 0. And what you should do with these problems, if you have extra time, is you should always take some of these ordered pairs, plug the x value into your modified function, and make sure you get the proper y value. It's just a good thing to do to check your work. All right, let's plot our points on the graph. So I've got -2, 0. Easy enough. I've got 1, 1. Okay. I've got 4, 2, right up there. I've got 7, 1, and 10, 0. Oh, I can see the absolute value graph there. It just looks a little bit different because of that -1/3, which caused a shrink. Now, even though none of our sample ordered pairs that we're using appear below the x-axis, it's important to know that that's just because we didn't pick the right ordered pairs to be down there. So this graph does keep on going like this, meaning that its domain is negative infinity to infinity, just like the normal absolute value graph. But the range does go all the way down to negative infinity, and it caps out at the y value of 2. All right, so now we've seen a vertical shrink at least with a nasty fraction. They are doable, but yeah, they're a little bit trickier. I hope that helped. Thanks for watching.